Finding details on one particular repair could take time. There's something about this particular doubler that catches Frank Zakar's attention.
The outside of the fuselage contained longitudinal streaks that appear to emanate from between the doubler plate and the skin.
Something is leaking from underneath the metal patch.
Was there a possibility that the skin had broken, cracked, and was there any fuel or air coming out from between the doubler and the fuselage? And that warranted further examination.
Let's cut it from here to here and send this piece to Chongshan.
In order to see what's underneath the doubler, a large section of piece 640 is sent to a lab. No evidence has been found of structural or mechanical problems with Boeing 747-200 airplanes. Taiwanese aviation officials have no reason to keep the planes on the ground. The Chongshan Institute of Science and Technology is a military research facility. It's at the forefront of Taiwan's space program. This is where investigators take a section of piece number 640 for a closer examination. The NTSB's Frank Zakar finds a telling clue on the crack itself.
When I looked at the fracture surface, I found that this one specific area was covered with aluminum oxide, pretty much similar to rust on a car.
Years of exposure to oxygen changes the color of metal. The discoloration tells investigators that this particular crack at the rear of the airplane has been there for a very long time. Then, when the doubler is finally removed, investigators get a look at the aluminium skin underneath. They're intrigued by what they see.
When we disassembled the doubler plate from the skin, we noticed that there were some fairly long gouge marks.
This is beyond the kind of damage a doubler is meant to patch.
That was an aha moment that we might have something here.
The search of the plane's documents also pays off. The records contain a very short reference to a mishap 22 years earlier, when this plane was only 6 months old.
Speed is low, sir. Watch it.
Its tail scraped the runway while landing.
Did you feel that?
It happens when a plane lands or takes off at too steep an angle. It's called a tail strike.
009 Hong Kong Tower. We observed smoke and sparks from your tail on landing.
Roger, Hong Kong Tower. We'll have that looked at. Tail strike, sir. I better log that.
It is a relatively common occurrence. It's not a good thing. Some airplanes even have what's called a bumper in that portion of the aft fuselage, so that if the tail ever does get too close to the ground, instead of sacrificing skin from the fuselage, you might have the sacrificial bumper that will take that wear.
Tail strike damage is routinely repaired. Investigators want to know how China Airlines went about fixing the plane. They can only find a brief mention of the repairs that were done in the plane's logbook.
That's all there is?
That's all we could find.
There's not a lot of detail in China Airlines records.
China Airlines indicating they could not find any of those documents. And when we start looking for it, we could not find any. And they said they probably got lost.
The documents that do exist show that the day after the tail strike, China Airlines did a temporary repair. Workers attached a large aluminium plate over the damaged area.
What do we know about the permanent repair?
It doesn't get much better.
A more permanent repair was to be carried out within 4 months.
This is what we got.
The maintenance records indicated that the permanent repair was done in accordance with Boeing recommendations in their structural repair manual.
evidence that we uncovered indicate that the repair was not done per the Boeing repair manual.
According to the manual, many of the scratches on the plane were too deep to be repaired. The entire damaged section should have been cut out and replaced.
You have to follow certain procedures, and the Boeing structural repair manual indicating very clearly what you should do step by step.
22 years later, investigators can tell that for some reason the damaged piece was not replaced. The scratches from the tail strike are still there. China Airlines engineers tell investigators that the scratched area was too large to cut out, so they sanded the scratches down instead.
In the event of scratching, it depends on how deep the scratches are. If they're not very deep, they can be blended out, but if the scratches are too deep, the repair technique that's called for is to actually cut out all of the scratched material and then design a doubler patch that's larger by a big percentage of the structure that was originally removed.
The scratches weren't sanded down or cut out. They're still there. Maintenance workers then made one final mistake.
They put the doubler plate right over the scratched material. The doubler plate that they put on was not 30% larger than the affected area. In fact, it was barely, maybe not even in certain locations, larger than the area that was scratched.
Even though the repair wasn't done according to Boeing's instructions, the way it was logged made it seem like it was. So for 22 years, anyone reading that entry would assume the damaged area had been cut out as it should have been.
Pieces were really starting to fall into place now. Once we saw this piece of structure that had the fatigue cracks in it, and we realized that it came from a structural repair that was not done properly, that was left to fly for 20 years.
Airborne passing 1,600.
Things began to make sense.
By covering an improper repair with a doubler, and then documenting the repair as meeting Boeing standards, the workers made their mistake impossible to detect.
What was so insidious about this improper repair was that the doubler plate hid all of the damage. So if you weren't there watching them do this repair improperly, you wouldn't know that it was done improperly. You would have assumed that the structure underneath had been cut out the way it was supposed to.
And every time the plane took off over the next 20 years, the concealed problem got worse and worse. The air inside a commercial airplane is pressurized. As the plane climbs, air is forced into the cabin to keep the pressure inside the plane greater than the pressure outside. It's like inflating a tire. The inside air pushes against the plane's skin.
Each time the airplane pressurizes, pressure builds up inside the fuselage of the airplane. That crack could open up for a certain amount of inches or microns or millimeters.
The plane's skin expanded and contracted a little bit every time. Because they weren't properly repaired, the cracks grew and spread. Eventually, the crack grew into a stunning 2.3 meters.
If you were charting the crack, you would have seen very slow growth early, but as time went on, the growth was getting bigger and bigger.
A small scratch had grown into an enormous problem. Then in May 2002, as Flight 611 climbed, that problem killed 225 people.
As the airplane climbed in altitude and the fuselage was pressured, that put enough strain on this growing crack that it reached its critical length. And from there, it just spread like a spider web. It went in all directions, and it probably looped all the way around the fuselage to the point where the entire aft section of the airplane just broke off from the rest of the structure.